There are moments in mobility design when architecture quietly replaces automotive convention, and what stands before me here is less a motor home and more a rolling piece of structural sculpture engineered around long-distance autonomy. Before we go any further, it's important to frame this correctly. What I am analyzing is a speculative AI-generated concept, a fictional exploration of what ultra-luxury, long-range recreational mobility could become. It does not exist as a production vehicle, nor is it a preview of an announced platform. Instead, it functions as a design study, a thought experiment in scale, proportion, and systems integration. Now, standing in front of it, the first impression is not excess, it is control. This concept appears to stretch approximately 45 to 48 feet in overall length, placing it firmly in the upper echelon of Class A motorhome dimensions. The height seems just under 13 feet, judging by the entrance stair geometry and glass proportioning, which suggests compliance with typical North American highway clearance thresholds. Width is likely near the legal maximum of 102 inches, yet the body sculpting visually narrows the mass, preventing it from feeling overbearing. The wheelbase logic is particularly interesting. We're looking at a tri-axle rear configuration, two closely spaced rear drive axles, and a forward steering axle. This indicates an engineering assumption of extreme curb weight, likely north of 22 to 25 metric tons if fully equipped. The tandem rear axle distributes load more evenly, reduces per-axle stress, and increases straight-line stability at highway speeds. What matters here is not simply that it has three axles, it's how the wheel placement relates to the cabin mass. The front axle is pushed forward aggressively, minimizing front overhang and improving approach geometry. The tandem rear sits slightly aft of the geometric center, implying rear weight bias, logical for a motorhome where utilities, water tanks, battery systems, and sleeping quarters are typically rearward. The stance feels planted, not tall. That is achieved through body tapering and a relatively low belt line that visually compresses vertical height. The glazing band, dark, continuous, and wraparound, acts as a horizontal visual anchor that slices the height in two. Unlike conventional RV architecture, which tends toward box section construction for volume efficiency, this concept abandons vertical flat planes in favor of tensioned, flowing surfaces. The nose is sculpted with a pronounced forward rake, and the windshield wraps around in a near panoramic arc. This reduces stagnation pressure at the front face and guides airflow along the curvature of the roof rather than allowing it to detach abruptly. The roofline is especially sophisticated. Notice the slight dorsal spine contour running longitudinally. That ridge is not decorative. It suggests airflow channeling toward the rear, possibly managing laminar flow and reducing turbulent wake separation. Side surfaces carry a marine-inspired sweep, a gesture reminiscent of luxury yacht hull geometry. There is a deliberate avoidance of sharp creases. Instead, we see curvature continuity, long radii transitions that maintain surface tension without breaking airflow prematurely. Panel seams are virtually invisible. This suggests either a composite monocoque approach or highly integrated modular panels with precision flush bonding. In a real-world engineering scenario, such continuity would likely require large-format carbon fiber reinforced polymer sections or aluminum honeycomb composite skins bonded to a structural space frame. The lower rocker area features subtle vent-like sculpting. These may function as aerodynamic extractors, allowing high-pressure air from the wheel wells to dissipate efficiently. On a vehicle of this size, wheel arch turbulence is significant, so airflow evacuation would meaningfully impact drag coefficient. The finish appears to be a multi-layer metallic silver with deep reflective index. Under direct lighting, the curvature reveals microflake diffusion, likely a ceramic-infused clear coat layered over a metallic base with pearlescent undertones. Why this matters is thermal behavior. Lighter metallic finishes reflect solar radiation more effectively than darker pigments, reducing interior heat absorption during prolonged exposure. For long-haul mobility platforms, passive thermal control is essential for energy efficiency. The glazing band is deeply tinted, possibly electrochromic smart glass in concept form. The density suggests solar heat rejection properties exceeding conventional RV glass. In practice, achieving this scale of structural glass would require laminated multi-layer safety glazing with embedded UV and IR filtration layers. The transition between paint and glass is executed in a seamless wraparound manner, almost aerospace in its cohesion. The front lighting signature is restrained but deliberate. Slim LED daytime running lights stretch laterally, emphasizing width. Beneath them, primary beams appear recessed, possibly adaptive matrix LEDs integrated into the lower fascia. The lighting hierarchy is intelligent. DRLs define visual identity. Primary beams serve function. Accent blue illumination appears to trace aerodynamic channels, a design choice that leans toward future-forward electric identity language. At the rear, though not fully visible here, one would logically expect a full-width light bar, given the front's horizontal emphasis. Symmetry and continuity are central to this design vocabulary. The polished multi-spoke wheels suggest forged aluminum construction rather than cast. The reflectivity indicates high-end finishing, likely clear-coated to resist oxidation. Tire profile appears highway optimized, low sidewall deflection relative to traditional RV tires. This implies a suspension system engineered for dynamic stability rather than purely cushioned ride. Given the tri-axle layout, I would anticipate electronically controlled air suspension with active leveling. Such a system would compensate for crosswinds and weight distribution shifts, especially with water tank depletion or cargo changes. Ground clearance is modest but not low. It suggests urban and highway optimization rather than off-road expedition use. The roof paneling shows subtle segmentation that could plausibly house integrated solar arrays beneath a protective polycarbonate or glass composite. Given the vehicle's scale, realistic solar contribution might yield 1.5 to 3 kilowatts under optimal conditions, sufficient to offset auxiliary loads but not primary propulsion. The dorsal ridge may also conceal satellite communication domes or autonomous sensor clusters. For a forward-looking concept like this, semi-autonomous highway piloting would be logical. Interestingly, the front grille area is minimized. That implies either a fully electric or hybrid electric architecture requiring less frontal cooling than a diesel-based RV. Cooling apertures are sculpted low, suggesting active airflow management, possibly adaptive shutters that open only when thermal load demands it. This is where the design begins to separate itself from traditional motorhomes. Conventional RVs borrow heavily from commercial truck front ends. This concept rejects that lineage entirely. It feels more aerospace and marine than commercial trucking. This vehicle redefines the luxury motorhome not as a utilitarian box with residential grafting, but as a mobility architecture object. It leans heavily toward yacht-inspired surfacing, aerospace glazing integration, and executive automotive lighting language. The intended user archetype is not the seasonal camper. It is the globally mobile executive, the design-conscious explorer, or the long-duration remote operator seeking environmental control without aesthetic compromise. From a design maturity perspective, the exterior appears remarkably cohesive. There are no competing gestures. Every line supports forward motion and visual elongation. Professionally, I find it conceptually persuasive, not because it is dramatic, but because it is disciplined. Although we are primarily observing the exterior, the structural logic allows us to reverse engineer a plausible interior architecture. Given the triaxle chassis and probable composite superstructure, I would expect a reinforced aluminum or carbon fiber space frame integrated with structural floor beams. The glass-to-body ratio suggests that structural rigidity would rely heavily on lower beltline reinforcement and roof ring frames. Ceiling height likely approaches 7.5 to 8 feet internally, given exterior height proportions. That allows for full residential standing clearance without compromising roof aerodynamic taper. Slide-out sections are not visible externally. This implies a fixed-width design prioritizing rigidity and aerodynamic efficiency over expandable interior volume. The rear likely houses a master suite positioned over the tandem axles. This is logical for ride comfort. Suspension articulation is most stable between rear axle sets. Large panoramic side glazing would require electrochromic dimming for privacy and thermal control. Acoustic lamination would be essential for highway noise attenuation. Midship kitchen placement would balance weight distribution between front cockpit and rear sleeping quarters. Given assumed electric or hybrid propulsion, induction cooking surfaces would be more feasible than propane systems. Water storage could approach 150 to 200 gallons combined fresh and gray water capacity. Gray water recycling filtration could extend off-grid economy significantly. A modular separated wet bath is most plausible. Ventilation would require active humidity extraction systems integrated into roof channels. Water heating would likely be heat pump assisted rather than purely resistive, improving efficiency. The cockpit glass curvature suggests exceptional forward visibility. I would anticipate augmented reality projection across the lower windshield band, providing navigation overlays and lane guidance. Semi-autonomous Level 3 highway capability would be a logical inclusion in a forward-thinking concept. Control ergonomics would likely favor horizontal digital interfaces rather than vertical stacks, maintaining line-of-sight discipline. A hydrogen-electric hybrid system would align well with the minimal front grille and clean underbody shaping. Battery density assumptions of 250 to 300 watt-hours per kilogram would allow substantial onboard storage without excessive mass penalties. Regenerative braking across 3 axles would meaningfully contribute to range recovery during descents. Realistically, off-grid autonomy could approach 4 to 7 days, depending on climate control usage. Multi-zone climate management would be mandatory at this scale. AI-driven load balancing could monitor structural strain, tire pressure, and suspension height dynamically. Satellite connectivity integrated within the roof spine would support remote work, streaming, and navigation redundancy. Long-distance touring is clearly the design intent. However, terrain limitations would confine it primarily to paved infrastructure. Urban maneuverability would require rear axle steering to mitigate turning radius challenges inherent to nearly 50-foot platforms.
To realize something like this in tangible form would require breakthroughs in lightweight composite manufacturing at scale. Structural glass technology would need to advance in impact resistance while maintaining weight efficiency. Battery energy density would need continued improvement to offset mass from luxury amenities. Is it evolutionary or revolutionary? In design language, it is evolutionary, borrowing from marine and aerospace trends already visible in high-end mobility. In integration discipline, it edges toward revolutionary because it rejects commercial truck underpinnings as its starting point. What impresses me most is not extravagance, it is coherence. Every surface, proportion, and implied system appears resolved around a single thesis: that luxury mobility can be aerodynamic, intelligent, and architecturally refined without resorting to visual noise. As a speculative concept study, it invites a compelling question. Not whether we can build something like this tomorrow, but whether the future of long-range personal mobility should begin thinking less like a vehicle and more like inhabitable architecture in motion.